Uranus, the seventh planet from our Sun, is a true wonder of our solar system. This pale blue giant is unique among its planetary siblings. Why? Uranus spins on its side. Imagine a planet tipped over, rolling around the Sun like a marble. That's Uranus. This unusual tilt gives Uranus extreme seasons unlike anything we experience on Earth. Uranus is also an ice giant, a world very different from our rocky home. Its atmosphere is made of hydrogen and helium, with a good amount of icy elements like water, ammonia, and methane. Join us as we explore Uranus, a planet of mysteries and surprises. Uranus was not known to ancient civilizations like some of its planetary neighbors. Unlike Jupiter and Saturn, which are visible to the naked eye and have been observed since ancient times, Uranus remained hidden in the depths of space, waiting for the right moment to be discovered. It was too faint to be easily seen with the naked eye. Its dimness and slow orbit made it easy to overlook, blending in with the countless stars in the night sky. Uranus was officially discovered in 1781 by astronomer William Herschel. Herschel, a musician by profession, had a passion for astronomy, and spent countless nights observing the heavens with his homemade telescopes. At first, Herschel thought he had found a comet. He noted its movement across the sky and its fuzzy appearance, which was typical of comets. However, further observations showed that it moved like a planet, in a steady orbit around the Sun. Unlike comets, which have highly elliptical orbits, Uranus followed a more circular path. This was a major discovery, the first time a planet had been found using a telescope. Herschel's discovery expanded our understanding of the solar system and demonstrated the power of telescopic observations. Uranus is about 4 times wider than Earth and much farther away. Its diameter is approximately 31,763 miles, making it the third largest planet in our solar system by diameter. It's located about 1.8 billion miles from the Sun, taking 84 Earth years to complete one orbit. This vast distance means that a single year on Uranus is equivalent to a human lifetime on Earth. Because of this distance, Uranus receives far less sunlight than Earth, making it a very cold world. Its average temperature is around -224 degrees Celsius, making it one of the coldest planets in our solar system. The most striking feature of Uranus is its extreme tilt. Unlike any other planet in our solar system, Uranus has a unique orientation that sets it apart. This unusual tilt gives Uranus a distinctive character and influences many of its other characteristics. While most planets spin like tops, with their axis of rotation nearly upright, Uranus does something entirely different. Imagine a spinning top that has been knocked over, lying almost flat on its side. This is how Uranus rotates, creating a fascinating dynamic that is unlike any other planet in our solar system. Uranus is tilted on its side at an angle of 98 degrees. This extreme tilt means that the planet's axis of rotation is almost parallel to the plane of its orbit. Such a dramatic tilt is not seen in any other planet, making Uranus a subject of great interest and study. This means its poles point almost directly at the Sun for part of its orbit. As Uranus travels around the Sun, each pole gets a turn to face the Sun directly, leading to unique and extreme seasonal changes that are unlike those on any other planet. Astronomers believe this dramatic tilt was caused by a giant collision long ago. The theory suggests that a massive object, possibly a protoplanet, collided with Uranus, causing it to tip over. This cataclysmic event would have had a profound impact on the planet's orientation and its subsequent evolution. Imagine a young Uranus being struck by a large object, maybe even another planet. The force of such a collision would have been immense, enough to knock Uranus onto its side. This event would have forever altered the planet's axis and its path through the solar system. This impact could have knocked Uranus onto its side, forever changing its destiny. The planet's unique tilt has significant implications for its climate, weather patterns, and even its magnetic field, making it a fascinating subject for scientists and astronomers. This tilt results in the most extreme seasons in our solar system. Each pole experiences 42 years of continuous sunlight followed by 42 years of darkness, creating a cycle of extreme seasonal changes that are unlike anything we experience on Earth. During a Uranian summer or winter, one pole faces the Sun continuously for decades, bathing it in unending daylight. This prolonged exposure to the Sun's rays leads to significant temperature variations and unique atmospheric conditions, while the other is shrouded in darkness. This extended period of darkness plunges the opposite pole into a frigid, shadowy winter, creating a stark contrast between the two hemispheres of the planet. This leads to bizarre weather patterns and temperature variations. The extreme tilt and the resulting seasonal changes cause unusual weather phenomena, including powerful winds and storms, making Uranus a planet of extremes and a subject of endless fascination for scientists. Uranus is not alone in its celestial dance. It is surrounded by a system of thin, dark rings. Unlike Saturn's bright, icy rings, Uranus's rings are composed mostly of dust and small rocky particles. These rings were discovered in 1977, not by directly observing them, but by their effect on starlight. Astronomers watched as Uranus passed in front of a distant star. As it did, the star blinked on and off, several times before and after the planet itself passed by. These blinks revealed the presence of the rings. 13 distinct rings have been identified so far, each with its own unique characteristics. Scientists believe these rings are relatively young and may have formed from the breakup of a moon or moons long ago. Uranus has a large family of moons, with at least 27 confirmed orbiting the planet. These moons are named after characters from the works of William Shakespeare and Alexander Pope, adding a touch of literary flair to the Uranian system. The 5 largest moons are Miranda, Ariel, Umbriel, Titania, and Oberon. Each moon is unique and fascinating. Miranda, for example, has one of the most varied and jumbled surfaces in the solar system, with giant cliffs, canyons, and strange, grooved features. Scientists believe these moons may hold clues to the formation and evolution of the Uranian system, providing insights into the early solar system itself. Uranus also possesses a magnetic field, but it's unlike any other in our solar system. Unlike the more familiar magnetic fields of Earth or Jupiter, Uranus's magnetic field is a true enigma, presenting scientists with a puzzle that has yet to be fully solved. Earth's magnetic field, generated deep within our planet's core, acts like a giant bar magnet, with a north and south pole. This field is relatively stable and predictable, providing a protective shield against solar radiation and cosmic rays. In stark contrast, Uranus's magnetic field is tilted at a bizarre angle compared to its axis of rotation and is offset from the planet's center. This means that the magnetic poles of Uranus do not align with its geographic poles, creating a highly unusual magnetic environment. This strange magnetic field suggests that Uranus's magnetic dynamo, the process that generates the field, works very differently than Earth's. While Earth's dynamo is driven by the movement of molten iron in its outer core, Uranus's dynamo might be influenced by different materials and processes, possibly involving a layer of ionic or superionic water. The magnetic field of Uranus is also surprisingly complex and dynamic. It fluctuates and changes in ways that are not yet fully understood, indicating that the internal structure and composition of Uranus are quite different from those of Earth or other planets in our solar system. It creates a lopsided magnetosphere, the region around a planet dominated by its magnetic field. This lopsided nature means that the magnetosphere of Uranus is not symmetrical, leading to unique interactions with the solar wind. This unusual magnetosphere interacts with the solar wind in unexpected ways, leading to auroras that shimmer and dance across the planet's polar regions. These auroras are different from those on Earth, both in their appearance and in the processes that create them, adding another layer of mystery to the magnetic field of Uranus. Our only close-up look at Uranus came from NASA's Voyager 2 spacecraft, which flew past the planet in 1986. During its flyby, Voyager 2 captured stunning images of Uranus, its rings and moons, revealing their beauty and complexity for the first time. Voyager 2 also made important measurements of Uranus's atmosphere, magnetic field, and internal structure. The data collected by Voyager 2 revolutionized our understanding of this distant ice giant. However, Voyager 2's flyby was brief. It was like taking a quick snapshot of a fascinating stranger as you pass them on the street. Many questions about Uranus remain unanswered. Despite its distance and the challenges of reaching it, scientists are eager to return to Uranus. A dedicated mission to Uranus equipped with advanced instruments could unlock many of its secrets. A future mission could study Uranus's atmosphere in detail, revealing its composition, temperature, and weather patterns. It could map the planet's gravity and magnetic fields, providing insights into its internal structure and the workings of its unusual magnetic dynamo. A Uranus orbiter could also study its rings and moons, providing clues to their formation and evolution. By unraveling the mysteries of Uranus, we can gain a deeper understanding of the diverse planets that populate our universe. Uranus is not just a curiosity of our solar system, it represents a class of planets known as ice giants, which are thought to be common in the Milky Way galaxy. Ice giants, with their deep atmospheres, icy interiors and systems of rings and moons, present unique challenges and opportunities for scientific exploration. By studying Uranus in detail, we can learn more about the formation, evolution, and diversity of planetary systems throughout the cosmos. Uranus, the tilted ice giant, is a reminder that our solar system is a place of endless wonder and discovery. Its mysteries beckon us to explore further, pushing the boundaries of our knowledge and expanding our understanding of the universe we call home.